Question 2. When a battery is used in a circuit, current also flows through the battery. The chemicals inside the battery have resistance, and this will affect the current. Describe what happens when a battery goes flat. Well, a battery is simply a power source. Now, inside a battery is an internal resistor. Okay, the voltage across the power supply is also known as epsilon. Epsilon is the electromotive force. This is the force that moves the electrons around the circuit. When the battery gets old, this resistance here gets worse, okay, or gets higher. Now, what we measure when we connect a voltmeter to a battery is this voltage here, known as the terminal voltage. Now, if I wanted to know how much voltage, or what that voltage is across the terminals, it's going to be epsilon, the electromotive force, take away the amount of voltage lost across this resistor. Okay. Now, if that resistor has got a value of R and there's a certain amount of current going through that, then that voltage across that resistor is going to be IR. So the amount of voltage I'm going to measure here is going to be this voltage, take away the voltage across here, which is going to be IR. Now, as the battery gets older, R is going to go up, and if R goes up, that means this whole value goes up. That means there's going to be less voltage here. There's less voltage there, that's why it goes flat. Now, there is a chemical reason behind that, but that's more to do with chemistry. If we look at the model answer, it says as the battery goes flat, the chemical makeup of the battery changes in such a way that the internal resistance R in the circuit up here of the battery increases. This happens to such an extent that with normal use of resistance loadings, its available voltage drops away significantly from its electromotive force epsilon, meaning that the battery goes flat. Instead of having 1.5 volts, you might have 0.2 or 0.4 of a volt, which doesn't work in the circuits, and so your camera doesn't turn on, for example.